In this video, we will solve unsolved problem solution of Donald Niemann electronic circuit analysis and design. So the question states that calculate the intrinsic carrier concentration in silicon at T equal to 275 Kelvin and T is equal to 325 Kelvin. And we have to repeat this part for gallium arsenide also. So before going there, we need to have some data for solving this question, but we need to know the formula first. So the intrinsic carrier concentration is given as B into T raised to 3 by 2 into E raised to minus Eg by 2 kT, where B is the semiconductor coefficient. It is a constant for given material like silicon, gallium arsenide. There will be different values. Temperature is Kelvin. Eg is the band gap for the silicon and germanium, and K is Boltzmann constant, and it should be in electron volt per Kelvin, not in joule per Kelvin, because you can see that Eg here is in electron volts, so that will cancel out and that will be easy for solving the question. Okay, so let's see what is the data for silicon and gallium arsenide. So the value of B for silicon is 5.23 into 10 to 15, and this is 1.1 electron volt, and this is centimeter की power -3 and K raised to -3 by 2. And for gallium arsenide, it is 2.10 into 10 to 2.10 into 10 to 14 per centimeter cube per cube root of Kelvin. And in gallium arsenide, we have band gap of 1.4. Now we can calculate for the both. Okay, for A and temperature 275 and 325 we will start. Okay, so let us just proceed with this. I will try to finish in this page only. So in this part I will solve for T equal to 275 Kelvin, and here I will solve T equal to 325 Kelvin. So can you see, we have Ni is equal to B into T raised to 3 by 2. So B we can put 5.23 into 10 raised to 15 into 275 raised to 3 by 2 into E raised to minus 1.1 by 2 into, now this is K, and K is equal to 86. K is equal to 86 into 10 raised to minus 6 electron volt per Kelvin. This we have to substitute here. So this is 86 into 10 raised to minus 6 into, again we have the temperature 275, and if you solve this you will get the answer of the first part, that is equal to 1.9 into 10 raised to 9 per centimeter cube. 1.9 into 10 raised to 9 per centimeter cube. In this case, if you put the same value, so that is 5.23 into 10 raised to 15 into 325 raised to 3 by 2 into e raised to minus 1.1 by 2 into 86 into 10 raised to minus 6 into 325. So here we will get Ni is equal to 8.71 into 10 raised to minus 10. 8.71 into 10 raised to minus 10 raised to 10, not minus, 10 raised to 10 per centimeter cube. So we have done for the silicon. Now we have to proceed for gallium arsenide. Okay, gallium arsenide. So let me zoom it so that we have enough space for doing this question. Okay, fine. So Ni, let's solve for Ni at the 275 Kelvin. So how we will go with this? We can solve this with the formula. So 2.10 into 10 raised to 14, right? Just a minute. Okay, 2.10 into 10 raised to 14 into temperature is 275 raised to 3 by 2 e raised to minus 1.4 by 2 into 86 into 10 raised to minus 6 into 275. So here we will get Ni is equal to 1.34 into 10 raised to minus 10 raised to 5, 1.34 into 10 raised to 5 centimeter per centimeter cube. And when T is equal to 325, we have to plug in 325 at the place of T. So it is 2.10 into 10 raised to 14 into 325 raised to 3 by 2 e raised to minus 1.4 by 2 into 86 into 10 raised to minus 6 into 325. So here we will get 1.63 into 10 raised to 7, 1.63 into 10 raised to 7 per centimeter cube. Please subscribe for more videos and appreciate my work so that I can make more solutions of all the books. Thank you.